evaluate limit of sine x over x as x goes to infinity. If we directly substitute x equals infinity, so we have infinity on the bottom, but sine of infinity, there is no value. Okay, sine of infinity is not infinity, by the way, so we don't know, because sine graph, if we look at sine, so when x goes to infinity, that means x becomes bigger and bigger. We just get a value in between 1 and -1. Okay, all the values in between -1 and 1. So we don't know, but at least now we have some idea. The sine of any angle is squeezed between -1 and 1. So let's use that fact, and we might be able to use the squeeze theorem. Okay, sine, cosine always squeeze between -1 and 1. So note that sine of any angle, in this case x, is in between -1 and 1. Okay, now we have sine x over x, so we can divide this compound inequality, in fact we have three sides, by x, so that we get sine x over x in the middle. So divide each side by x, so -1 over x x. Okay, this expression is squeezed between these two functions. Let's find the limit of this. Limit of -1 over x when x goes to infinity, that's the case. So 1 over very big, that means very small, 0, -0 in fact, but -0 is same as 0. Similarly, when we find the limit of this 1 over x when x goes to infinity, 1 over infinity, 1 over very big, 0. That means when x goes to infinity, this is squeezed between 0 and 0, because this one is approaching to 0, this is going to go to 0, this is also going to go to 0. That means the limit of this expression is 0 as well. Thus, by the squeeze theorem, limit of sine x over x as x goes to infinity is equal to 0.